Hello, Dr. Fauzi. My name is Henry, the group leader for Group 1. And today, we will be discussing about our case study on the application of quality control tools on improving the productivity of the electronic manufacturing services, Plexus Corporation. Our study focuses on identifying the primary issues affecting productivity and analyzing their root causes and proposing effective solutions using advanced QC tools. Quality in the realm of quality control is about meeting customer needs and expectations. It encompasses attributes like functionality, reliability, durability, serviceability, and aesthetics. It's not just about the end product, but extends throughout the production process. Quality control tools are essential in the manufacturing industry for ensuring product reliability, customer satisfaction, and operational efficiency. Traditional QC tools like Pareto charts and Ishikawa diagrams have been instrumental in identifying and addressing quality issues. In our study, we also utilized the 7 new QC tools, which include tree diagrams, Ishikawa diagrams, affinity diagrams, interrelationship diagrams, and lastly, matrix diagram, to provide advanced techniques for problem solving and decision making. This case study delves into the utilization of 7 new QC tools at Plexus Corporation. These tools are crucial for overseeing operations and fostering continuous process enhancement. Our focus was on identifying the main problems at Plexus and determining the root causes, which we then propose recommended solutions to overcome these problems, which we then lastly evaluate the priority of these solutions by ranking them. And now, this study emphasizes the importance of mastering these tools to maintain competitiveness and operational efficiency in today's complex regulatory environment. Plexus Corporation, established in 1979, is a global leader in product design, development, and electronics manufacturing, specializing in sectors like healthcare, aerospace, and industrial realms. Plexus offers a wide range of services from engineering to supply chain solutions. Despite their strong marketing positions, maintaining a high quality standards amidst complex product designs and strict regulatory environments remains a significant challenge. Our research adapted a mixed method approach, primarily qualitative. We utilized the 7 QC tools to identify causes, propose solutions, and evaluate their effectiveness. Our methodology included document analysis, observational study, literature review, factory visits, interviews, and even surveys.
Plexus is a company that provides high-quality electronic manufacturing service. This flowchart demonstrates every important step in making sure that customer requirements are fulfilled, from initial design to final product delivery. The beginning of the process is getting to know customer requirement to better understand and define the project objective. It is important to know the requirement in order to evaluate the feasibility of the project. This step is critical for developing a project plan that is both organized and achievable. With a clear understanding of the requirements, the team moved on to the design and engineering phase. We utilized CAD technology to create tools, engineering blueprints, conduct simulation and cost examination to guarantee that the design can be manufactured efficiently, ensure that the design follows to all clients' requirements and industry standards. This phase converts the client's specification into a practical and manufacturable plan. Next, we concentrate on getting all the necessary materials, purchase all required materials from a reliable supplier, check that all materials are accessible to avoid manufacturing delays. Ensuring materials availability is critical for a successful manufacturing process. We then build and test a physical prototype to ensure that the model is functioning, check that the prototype fits all of the design requirements and it functions properly. This process allows the early discovery and resolution of any issues, while ensuring that the design is achievable. The following step is testing and validation, which is used for verifying the prototype's performance and reliability, ensure that the product fulfills all necessary requirements before mass manufacturing. Comprehensive testing is performed to guarantee that the product can withstand real-world circumstances and meets all requirements. Then, the company prepared for mass production by designing manufacturing lines such as SMT and soldering. We also need to do dry runs and system inspection to ensure that all equipment works properly. This stage guarantees that the manufacturing line is ready for efficient production. At Plexus, quality is key. We utilize technologies such as automated optical inspection, AOI, and X-ray inspection to ensure that the product fulfills all requirements, so we compare it to the quality standards. Strict quality assurance guarantees that only high-quality items is produced. In this final assembling step, we use both automated and manual processes to build a finished product. To optimize efficiency, we need to do evaluation and improve the assembling process. This phase combines all components into a fully working product. Once the product has been assembled, we will pack it using automated processes according to the client's requirement. We must guarantee that the packaging fulfills every necessary standard and customer requirement. Proper packaging, making sure that the product safety during the transportation, guaranteeing that it arrives in great condition. The final stage ensures a successful finish, confirm that all processes have been performed properly, ensure that the product is meeting every requirement from the client. This systematic approach ensures that each product meets Plexus' high standards and surpasses customer expectation.
My name is Danielle. My matching number is AP220245. Now I will explain about the problems that faces by Plexus company. There are many problems that happen in the manufacturing line, and the main problem is the quality problem. With the feedback from 50 people of their employees, quality problem accounted for 32% of the problems. This problem normally happen because of the product supplied by supplier are not quality and will affect the customer satisfaction, brand's reputation, and additional expenses. followed by the problem of supply chain delay, which comprised for 22% of problem. Supply chain delay issue included delays due to supplier issue, logistic challenges, or material shortage, which will impact the seamless flow of components needed for manufacturing courses, causing production schedule to be slowed down. The third problem is financial problem. There are employees stand out for this problem. There are many financial problems in the manufacturing line, such as unexpected expenses and emergency repair costs in organization. This will affect the company operation to invest in new technology and decrease the company competitiveness in the market. Next, the following problems is equipment malfunction, accounted for 40% of the problem. This category included situation of mechanical failures and maintenance problems that disrupt the manufacturing process. Safety problem also been a problem in manufacturing line problems, with a total of X%. Safety issue included risks of accidents, danger of work environments, and failures to enhance and adhere to safety standard. Hence, this issue will lead to problems of well-being and productivity of employees and increase the probability of insurance costs. Other than that, technical glitch accounted for 6% of the problems, representing challenges that disrupted the manufacturing process. This technical glitch prevent the seamless operation of machinery or technology in the production process, causing disruptions, delays, or reduced quality. Lastly, employee problem becomes the smallest problem in the manufacturing line, with a total of 2%. This obstacle can lead to higher turnover rate and low employee morale that often happen in the company. This problem normally causes to inefficiency in productivity, higher training costs to employees, and disruption in the workflow. That's all from me. Thank you.
My name is Cecilia Tan Wen Lee, and my matrix number is AP220162. Now I'll be continuing to identify the causes of the problem. Ishikawa diagram, which known as fishbone. For the machine categories, includes issues related to outdated technologies, equipment malfunctions, and lack of maintenance. Outdated technology contribute to frequent breakdown and inefficiencies, making it difficult for Plexus Co. to maintain consistent product quality. For the method category, which are poor workflow management, inefficient work process, lack of continuous improvement in actives. Lack of standardization procedure leads to variability in product quality, as different employees may follow different methods. For the material categories, focus on issues related to the raw materials used in production. Poor handling and storage of materials further contribute to quality issues, as damaged or contaminated materials enter the production process, and also inconsistent supplier quality, defect raw materials. For the man category, highlights problems relate to the human factors in the production process. It lacks of skills or training, high turnover rates, poor communications. Lack of skills or training among employees leads to operational errors and decreased productivity. High turnover rates results in a continuous need for training and loss of experienced personnel, which disrupt production consistency. Poor communication, including language barriers, leads to misunderstanding errors during the productions. For the measurement category, identify the problem relates to the data collect and monitoring. Poor measuring mechanism, inaccurate data collects, lack of regular calibration. Inaccurate data collections leads to incorrect analysis decision, result in products that do not meet quality standards. The environment category addresses issues related to the physical working conditions in the production areas. Poor lighting and ventilation reduce productivity and increase errors as workers struggle to perform tasks accurately under this condition. High levels and dust or contaminants damage equipment and products, leading to defect and increased maintenance costs. Poor workplace environments. Next, I'll be explaining the use of affinity diagram in our project. We identify 6 categories, which are machine, method, materials, man, measurement, and environment. For the machine category, which are maintenance issues, poorly collaborate equipment, inefficient machinery, outdated technology, integration issues with new technology. For the human categories, which are lack of skill or training, resistant to change of new procedures, high turnover rates, poor communication, and lack of team collaborations. For the method categories, which are inefficient work process, lack of standardization procedures, over-reliance on manual process, poor workflow management, and inadequate training on procedures. For the measurement categories, which are inaccurate data collections, lack of real-time monitoring, lack of performance metrics, ineffective monitoring and evaluation, and over-reliance on manual data entries. For the material categories, dependence on single source suppliers, supply chain distribution, inconsistent supply qualities, inventory management issues, and substances raw materials. In the environment category, which are poor lighting and vandalization, unsafe working conditions, higher noise levels, ergonomically unfriendly workplace, poor maintenance facilities.
My name is Han Yu Chen, number metric AP220238. I will highlight our analysis based on the interrelationship diagram to pinpoint key issues affecting to the organization. After we done the interrelationship diagram, we identify four main issues. First, inefficient use of machinery. Second, poor communication. Third, outdated technology. And the last is inconsistent supplier quality. Firstly, inefficient use of machinery, or we call it machines on idle, is a pivotal issue. It creates maintenance issues, disrupting operations and contributing to inefficient work processes that slow down productivity. This inefficiency can lead to high turnover rates as workers become frustrated with frequent machinery breakdowns and supply chain disruptions, interfering with production schedules. Secondly, poor communication significantly affects various areas. It leads to inefficient use of machinery due to misunderstandings and errors in operation and maintenance. This also results in the lack of performance metrics and poor team collaboration, which hinders collective productivity. Moreover, it causes inaccurate data collection, leading to unreliable information for decision making. Thirdly, outdated technology perpetuates inefficiencies by causing integration issues with new technology and leading to a lack of necessary skills or training among employees. This outdated technology is a barrier to modernization and streamlining operations, often stemming from a lack of continuous improvement initiatives. Fourthly, inconsistent supplier quality leads to the procurement of substandard raw materials and inventory management issues. This directly affects the quality of the final product and complicates inventory control, causing production delays and inefficiencies. Lastly, quality problem is central to our issues, influenced by inefficient use of machinery, outdated technology, substandard raw materials, lack of skills and training, and also inconsistent supplier quality. Addressing these root causes will enhance our overall productivity and product quality.
Hello, my name is Henry, and membership number is AP220253. Next, I will present our findings on the quality control practices at Plexus Corporation. Our focus will be on the tree diagram, which identifies the main problems in quality issues and proposes solutions to improve production quality and efficiency. The tree diagram helps us systematically to identify and address the root causes of quality issues at Plexus Corporation. It breaks down complex problems into manageable components and offers clear strategies for improvement. Based on our analysis, we identified our four main problems leading to quality issues. Firstly, inefficient machinery use. Secondly, poor communication. 3, outdated technology. And lastly, inconsistent supplier quality. Efficient use of machinery often leads to productivity losses and quality problems. To address this, we propose 3 strategies. First, regular maintenance. By implementing a robust preventive maintenance schedule to reduce unexpected breakdowns and ensure consistent production quality. For example, we can make regular checks and lubrication of CNC machines to prevent malfunctions and ensure precise operations. Secondly, as for optimizing production scheduling, using advanced scheduling software to minimize idle time and reduce bottlenecks. For example, real-time tracking tools to alert operators about maintenance needs or production priorities. Thirdly, we suggest to provide operator training operators on proper machine setup and maintenance tasks. For example, workshops. We can set up workshops on setting up injection molding machines to ensure better product consistency. Next, as for the outdated technology problem, reliance on outdated technology hampers efficiency and quality. Our strategies include investing in new technology, where we allocate a budget for modern tech machinery and equipment. For example, we can upgrade to up-to-state-of-the-art CNC machines for high precision. Secondly, we recommend to implement automation, introducing robotics and automated systems for repetitive tasks. For example, robotic arms for assembly and packaging to increase speed and accuracy. And lastly, to train employees on new technology by providing continuous training on new equipment and software. We could do this by applying hands-on workshop for new production planning software to enhance efficiency. The next problem would be poor communication. Effective communication is crucial for maintaining quality standards. To improve this, we recommend to improve internal communication channels, implementing tools like Slack or Microsoft Teams for better coordination. For example, using Slack channels for project-specific discussions to streamline information sharing. Secondly, we could also make strategic regular meetings where scheduling daily stand-up meetings and weekly team discussions to maintain transparency amongst the team. For example, weekly quality review meetings can help to track progress and brainstorm new solutions. Thirdly, and lastly, our strategy is to establish clear protocols, developing a standardized reporting format and escalating procedures. A clear protocol for reporting quality issues ensures consistent documentation and prompt responses. And lastly, as for the problem of inconsistent supplier quality, inconsistent raw material quality affects the final product. To tackle this, we propose to develop a supply quality management program by setting clear standards and conducting regular audits. For example, we can use supplier scorecards to evaluate performance and ensure quality compliance. Then secondly, we recommend to diversify the supplier base to reduce reliance on a single source supplier to mitigate risk supply. For example, sourcing materials from multiple suppliers to ensure steady and quality supply. Next, we also recommend to implement rigorous incoming inspection procedures, thorough checks of all incoming materials. For example, a dedicated inspection team performing visual and material testing before production can efficiently increase the quality of our products.
Next, I will be discussing the matrix diagram we used to select the best strategy of Plexus Corporation. Our goal was to identify a solution that not only enhances our manufacturing process, but also aligns with our key criteria, which are impact on quality, implementation costs, ease of implementation, and sustainability. Let us start with our first criteria. First, impact of quality. This was assigned the highest impact score of 10 because improving the quality of our manufacturing products is our top priority. An effective solution will significantly enhance our product quality. Second, implementation cost. Given an impact score of 6, implementation cost is crucial as it helps in reducing production costs. Keeping our expense in check is essential for the financial health of the company. Third, ease of implementation. This criteria was assigned a score of 5. Solutions that are easier to implement will cause less disruption and allow us to see benefits more quickly. Lastly, sustainability. With an impact score of 4. Sustainability ensures that our chosen solution remains viable and effective over the long term, supporting ongoing improvement and compliance with environmental standards. We evaluate 12 strategy options against this criteria. Each option was scored based on its potential to meet this criteria. Our matrix diagram revealed that the strategy with the highest total score was implement rigorous incoming inspection procedure. With a perfect score of 114. This scoring was calculated by multiplying the impact scores by the relevant weights and summing the results. By choosing to implement this rigorous incoming inspection procedure, we aim to achieve significant improvement in our process. This strategy will help us ensure the quality of incoming materials, reduce defects, and ultimately enhance the overall quality of our manufacturing products. It also aligns well with our cost, implementation, and sustainability goals. In conclusion, this detailed evaluation and scoring process has enabled us to make an informed decision. By implementing the highest ranking strategy, Plexus Corporation is poised to achieve substantial productivity improvements and maintain its competitive edge in the market.
So, as for our discussion, this report explores manufacturing issues at Plexus Corporation using the 7 QC tools. The tools that we have used includes Pareto chart, Ishikawa diagram, affinity diagram, interrelationship diagram, tree diagram, and lastly, matrix diagram. Not to forget, we also use flow charts. And now, our expectations towards this report was to conduct through a thorough analysis with traditional and modern QC tools, to propose innovative solutions prioritized with tree and matrix diagrams. And in overall, our goal, we have showcased our expertise to make it tangible contributions to organization's success through quality control and problem solving. As we reach the conclusion of our case study on Plexus Corporation, let's summarize the key findings and solutions that we have explored. Firstly, the detailed analysis of Plexus Corporation's quality control practices has provided us with a comprehensive understanding of the primary challenges within their manufacturing processes. By utilizing various quality control tools such as Pareto charts, Ishikawa diagrams, affinity diagrams, interrelationship diagrams, tree diagrams, and matrix diagrams, we systematically uncovered and categorized the primary issues faced by the company. Our findings indicate that the most significant problem affecting Plexus Corporation is quality issues, which are deeply rooted in several factors. These include inefficient machinery use, poor communication, outdated technology, and inconsistent supplier quality. Each of these factors contribute to the overall decline in product quality and operational efficiency.